Okay, today we are going to work on this base plate. Now you'll notice on the left of my screen I have a schematic open. This is the dimensions of this base plate. Now the reason that I have this open is because you as a student have to start learning how to read schematics in order to make these Autodesk Inventor parts rather than just following my videos step by step. So as I build this base plate, I'm going to be taking you through how to actually read these schematics. So let's go ahead and get started on a new part, just like we do with absolutely everything. We're going to create a 2D sketch, and let's go to the schematics. We need to find out the overall length right here. So when we look at the far right and the far left, we can follow up this leader line and see that this is 11 inches long. We need to look at the far right to figure out the overall width. We can see that it's 4 inches long. So this piece is going to start out as a rectangle, 11 inches long and 4 inches wide. So we've got that done. Now the next thing that you'll see in here is it's not just square corner rectangle like what we're used to. These corners are actually rounded over. Now we need to find what the radius is. So we're going to look at every single one, and this one has a dimension pointing at it, and it says R.50 TYP. That means that these radiuses are typically 0.5 of an inch. So that's what we're going to do. We're going to radius these at 0.5 of an inch. Now the way that I like to do that is just with some geometry. We're going to put in 4 points at each corner of the rectangle that we're doing right here. Now that we have 4 points in there, I'm going to dimension these so it's 0.25 away from each side. Now the reason that I'm doing that, 0.25, is because I can now take a circle, put it at that point, and it is 0.5, which is the diameter that I have right there, and hit enter. Now I've got a circle right there. From here, all I have to do is actually trim this. Trim the outside corners. Trim the circle portion. You can see I've got a radius piece. Now the one thing that this does confuse is the computer with sort of our dimensions right here. You can see my 11-inch line is sort of angled. So all I'm going to do is just delete that dimension. It's still 11 inches long, but now I have that. What I'm going to do now is just the same operation for my other 3 corners, but I'm going to pause the video for a second so you don't have to watch me do that. Okay, so I paused the video for a few minutes, and you can see now I have put a circle and trimmed every single corner. So much like in this design right here, where every single corner is radius, so is the design that I have right here. Now that we have our basic shape finished, we have to extrude this out. So let's look at our design to find the thickness of the object, and we see that right here, which is 0.5 of an inch. So that's what we're going to do here. We are going to extrude it out 0.5 of an inch. And there we have it. It looks remarkably similar so far. Now we have to start doing some of the geometry in the holes and everything. So if you look at this, there's 2 sides to this. There is a front side with 1, 2, 3, 4 holes, and there's a back side with a differing hole pattern. What this is saying is on our front side, which is this, all of our holes are through holes. You can see them correspond up with that. But on our bottom, there are some blind holes, or holes that do not go all the way through. Let's go ahead and start with our front side to actually do these holes. In order to do this, we're going to create a 2D sketch, and we are going to draw on the face of the object. Now you can see that all of these holes are located on a center line. You know that because it's dashed like a center line. So to make this a little bit easier on myself, I am going to use a construction line to actually draw right down the center, just like that. Now remember, a construction line is an imaginary line. It's not actually there. Now I'm going to locate 4 points. I do this because there are 4 differing holes right there. So 1, 2, 3, 4. And you can see that all 4 points are located along that construction line. Starting from the far left, this closest point, when I look at our design, I need to find out where it's located, and look at this hole, follow the leader line up, and it's 0.4375 away from the edge. So that is what I'm going to do. Dimension this 0.4375 away from the edge. Now our second hole, follow it up and over, it's 1.5 away from the edge. So dimension that, and it is 1.5 away from the edge. Our third hole, follow it up and over, 5.5 away from the edge. So that's right in the middle. Now our fourth hole, we look at this, it is 0.4375 away from the right edge. So we have to dimension that on the other side. 0.4375. Okay, so we have our points in where we want to put our holes. Click Finish Sketch, and I am just going to change this to the front view because now it's time to actually put in the hole. So right there, we have our hole menu up. And you can see that by default, all of the holes are actually selected. We don't want this because 2 of our holes are one size, 2 of our holes have different geometry. So what I'm going to do is deselect 2 holes. The hole on our right hand side has been selected by default, so I'm going to click the Shift key, unselect the middle hole, and unselect the hole on the right. So you can see those are no longer selected. Oops. Come on. Sorry about that. My computer is freezing up a little bit on me. Okay, so I had a bit of computer problems right there, so I just paused it for a second. But what I did was deselect these 2 holes by clicking the Shift key and clicking the point. And you can see they're no longer selected. They are blue. And the hole on the far left and the far right are still selected. Now looking at the hole on the far left and the far right on the design, we can see that this says 0.25 through with a V, which stands for a countersink. Diameter is 0.5, 82 degrees, and there's 2 of them. 1, 2. So looking at this, we are going to go to this, which is a countersink. Click countersink, and 0.25 through refers to the diameter, refers to this right here. So we are going to put 0.25 right there. Distance goes through right there, and 0.375 on this, it says it needs at 0.5, and it's 82 degrees. So we have 0.5, 82 degrees, and let's see, 0.25 through. So we've got that correct. Now we're going to click OK, and you can see that it has given us the exact hole that we need. Now you see that we have a little bit of a difficulty in our other points disappeared. That's not to worry whatsoever. What we need to do is go back to hole. You see what I did right here was go expand this, and when I hover over the sketch, it appears. I need to right click and put Share Sketch. So Share Sketch is right there, and you can see that my sketch is back. Now we need to put the other 2 holes in here. And when we follow this down, it says the diameter is 0.3125. It's a through hole, and there's 2 of them. So click on that. We are going to just click through hole, which is a drilled hole, change the diameter to 0.3125. Termination is through all, and click OK. So now we have our other holes. You can see, however, that there are still visible dimensions and everything. The way that you get rid of this is to go to Sketch 2, right-click, and uncheck visibility. So now those are gone. When we rotate this, make sure our holes and everything are good, and you can see we have a through hole and we have a countersink hole. Okay, so this is the pattern done on the front side. So when I click on front, this is what I see. There is also holes on the back side. So what I'm going to do is switch this over to the back right here. And I am going to create a 2D sketch on the back. The back is fairly easy when we actually look at the schematic for this. There are just 4 holes in the corner, and they are drilled and tapped holes. That says this. They go 0.2875 deep. There's 4 of them, 1, 2, 3, 4, and they use threads. So what I'm going to do is put a point in here, and you can see the point with the dimensions at least correspond with the center point of this. So you have a 0.5 radius. You can see that the point corresponds, or the hole corresponds with the midpoint of that radius. So what I'm going to do is put a point on each one of the center points of our geometry, and you can see the coincident constraint sort of popping in right there, which is a good thing. I've got the points put in, finish the sketch, and now we can actually put our holes in there. We are going to click this right here, which talks about a tapped hole. And the tapped hole allows us to determine sort of everything about this, about the holes in general. So what we want is, let's see, okay, so what we want is to change some dimensions or change some defaults right here. If you notice, right here it says 832 UNC, which is a thread designation. This symbol means that it goes deep. The depth is 0.2875, and there's 4. So we have 1, 2, 3, 4 holes there, and it's 832. So what I've done, we have a through hole. The distance is 0.2875. I've clicked thread. I've changed the size to 0.164, which corresponds to 832. It's right hand, full depth. So these settings are a little bit difficult. Let's just go through this. Through hole, click threads, found 0.164, which is 832 UNC, matches the same dimension right there. And all we're going to do is click OK. And when we zoom in really, really close, we should be able to turn this, and you can see that the interior of the hole is threaded. And each one will be like that. So let's see, we're going to go back to the front here. We have countersunk hole, we have our through holes, and we have our threaded holes. So this is a fairly complicated part. It's time consuming. This is one of our longer videos. But realistically, in the real world, you're going to be making parts, designing parts like this all the time. Stop this video, rewind, and replay as many times as you need in order to get the geometry, and in order to understand how to actually read schematics and transfer those schematics over to Autodesk Inventor.